Okay, in this question we have two cars that are colliding. It looks to me that it's a momentum related question. So for this, I will actually need to resolve the velocities into its x and y component. As you can see, the y is in positive in the vertical direction and x is positive towards the right. So I'll also be using car 1 as car A and car 2 as car B. Okay, so if I were to resolve the velocity for car 1, I will actually have V1 equals to VA cos 45 degrees plus, x plus VA sine 45 degrees y. Okay, which gives me VA square root 2 over 2 x plus VA square root 2 over 2 y. Okay, the same goes for car 2. So for car 2, V2 equals to negative VB x. Okay, and in the situation of momentum questions, you always use the situation where momentum, the total momentum of system in the initial situation is same as the total momentum in the situation after. So what I'm going to do is also get the final velocity. So this v final is the velocity where both of them merge and they travel at that direction. So that is 50 sine 30 degrees x plus 50 cos 30 degrees y. Okay, that gives me 25x plus 25 times square root 3y. Okay, so the first thing that we do for momentum, as I mentioned, total momentum of the system in the beginning is same as the total momentum of the system after. So if I write the complete equation, so momentum of car A or car 1 plus momentum of car 2, so the initial momentums, equals to the momentum after, so they're combined, so their masses are combined. Okay, so we have 2000 V1 plus 1500 V2 equals to 3500 V final. And if I divide by 500, this becomes 4, this becomes 3, this becomes 7. So I have 4 V1 plus 3 V2 equals to 7 V final. And now I substitute the velocities in, so I actually get okay, so 4 times VA square root 2 over 2 x plus VA square root 2 over 2y minus, plus 3 negative VB x equals to 7 times 25x plus 25 times square root 3y. Okay, so that gives me 2 square root 2 VA x plus 2 square root 2 VA y minus 3 VB x equals to 725x plus 25 square root 3y. Okay, so what I want to do is also group them together, so in terms of their vector components. So 2 square root 2 would be a minus 3 vb x plus 2 square root 2 a y equals to 175x plus 175 square root 3y. Okay, and so if I were to equate the respective velocity unit components, vector components, sorry, if I were to compare the left hand side with the right hand side, this will give me 2 square root 2 VA minus 3 VB equals to 175, while on the other side of for vector unit vector y, 2 square root 2 VA equals to 175 square root 3. So in this case, I will actually calculate, and I actually will get VA having the value of 107 kilometers per hour, while if I were to solve the equation here, I will actually get VB equals to 42.55 kilometers per hour. I forgot to mention in the beginning that I actually maintain the velocity in terms of the units of kilometers per hour, because in this question it actually doesn't really need you to convert to meters per second.